Hello, everyone, and welcome to the lecture of Internet of Things. I'm Neda, and today I'm going to talk about basic programming concept. We saw that MicroPython is an interpreted programming language, and this means that as a developer, you write Python py files in a text editor, and then put those files into the MicroPython interpreter to be executed. We talk about the story behind Python and MicroPython programming languages, and we got to know how to set up the development environment like VS Code, and we got an overview of its environment and got to know what is REPL, interactive mode. Also, we learn how to install MicroPython firmware on our PicoW. And if you don't remember, I give a little summary. You should have downloaded the UF2 file, and while you put your PicoW in a downloadable mode, drag and drop the UF2 file, and then the firmware will be laid down on your PicoW. And we also learn how to put the PicoW in downloadable mode. So it was like while press the bootable button on your PicoW, put the micro USB into the PicoW. So make sure your device is connected to your computer via USB or serial cable, and then open your VS Code, and you can write your code in VS Code, or you can write your code in the REPL. Starting with the very simple command here is print hello world, and as you can see, I wrote it in the REPL, and print hello world will print hello world. This is like this simple. But let's see what is the basic programming concept. The basics of MicroPython programming are learning syntax, which is a set of rules and guidelines that dictate how programming statements or commands should be structured and formatted in order to be recognized and executed by the computer. We can say it is the proper way of write code in a particular programming language. Syntax errors occur when code is written incorrectly or violates these rules, and can prevent the code from running properly or at all. We learn about variables and data types that in Python, MicroPython, such as strings, numbers, and lists, and how to work with them. Also, we will learn about operators, and we will understand how to use operators in MicroPython, such as arithmetic operators, comparison operator, and logical operators. Also, we will learn about control structures and learn how to use control structures such as if statement, loops, and function to control the flow of your program. And also we will learn about error handling, learn how to deal with errors during runtime. Let's start with syntax and comments. Syntax is indentation refers to the spaces at the beginning of a code line. MicroPython uses indentation to indicate a block of code, whereas in other programming languages, the indentation in code is for readability only. But in MicroPython, the indentation is very important. As you can see here, we have if 5 greater than 2 colon, print 5 is greater than 2. This print should be inside the if. I will teach you what is if a statement, how you should write it. As you can see here, this one is correct and this one is not correct. and you will give error. Python or MicroPython will give you an error if you skip the indentation. So the number of spaces is up to you as a programmer, but the most common use is 4. But it has to be at least 1. So here, this indentation is very important and you should care about it. You have to use the same number of spaces in the same block of code, otherwise MicroPython will give you an error. Such as example here, if 5 greater than 2, print 5 is greater than 2, and this print 5 is greater than 2, it's like a nested, while we need these two to be at the same level, like here. So the correct syntax here, that we should write these two print at the same level and without any indentation. Let's see what is comments. Python or MicroPython has commenting capability for the purpose of in-code documentation. Comments can serve as placeholders for code that haven't been written yet or needs to be revised later. And comments can help you troubleshoot your code by providing context and highlighting potential issues or areas for improvement. And comments also can be used to temporarily disable code that you don't want to delete entirely but don't want to run at the moment. Comments can be used to document specific functions or modules so that others, if they want to read your code, they can easily understand how to use them. And comments can also help you adhere to coding standards and best practices for making it clear what each part of your code is doing and how it fits into the overall program. So for example here, this is an example of comment. In MicroPython, we will use sharp to make the statement as a comment. So this line is the comment. This is a comment. And print hello world, and after that, this line also, this is a comment. And you wouldn't see anything in output. You will see hello world in output, but you wouldn't see any hello to students of IoT course because this is comment. Variables. Variables are containers for storing data types, data values. In MicroPython, variables are created when you assign a value to it. And MicroPython has no command for declaring a variable. For example, in Java, we say that int x equal 5. In this case, we are specifying that I wanna declare a variable as int. But here in MicroPython, we just say x equal 5, and when this assignment is happen, it knows that the type of x is int. For example, here a y equal hello world. In this quotation, it shows that this is a string. Another example here is x equal 5 and y equal John, and we want to print x and y. This will print 5 and John respectively in the terminal. You can also write this code in your terminal in the Py file, or you can write it in the rep and test and see the result. Declaring variables. Okay, as I said, Python has no command for declaring a variable, and it can even change type after they have been set. For example, here we have int x equal 5, and string y equal hello world, and here we have x. As you can see, we cannot have this int and string. It is not required. In MacroPython, we write like this: x equal 4 or 5, whatever value you want to assign, and after you assign it, also here it will understand this that the type of x is int, because an integer value is assigned to it. But after that, when you write x equal Sally, and this is in the quotation, it shows that it is a string. So x now is of type of str or string. So we can see that we can change the type of the variable by assigning. So when we write print x, this will print Sally in the terminal. First it was 4, then we assigned it a new value to this variable, and when we do print x, we will see Sally in the terminal. In variables, we have casting. If you want to specify the data type of a variable, this can be done with casting. For example, you want to say that x is a string. Then it means that x will be a string 3 as a string. You can see here the single quotation. And when we say y is equal int 3, y here will be 3. 3 as integer is number here. This is not a string. So, and when you say z equal float 3, z will be 3.0. It shows that this is a float number. We are specifically saying that what is the type of our variable by casting. In variables, you can get the type of your variable. You can use the type function, like here in this example. We have x equal 5 and y equal John. When we print type x, and we will get int. When we print type y, we will get a string. Maybe you ask, oh, sometimes it's single quotation, sometimes it's double quotation. There is no difference, and they are the same. If you write it here or write it here, they are the same. Variables are case sensitive. When you choose a variable names in MacroPython, they are case sensitive. It means that a small is different from a cap. A is equal 4 and a is Sally, and this a will not overwrite this a. But if it was a equal 4 and then again small a equals Sally, then in this case it will override a and the output will be Sally. Let's see how we should choose the name for a variable. A variable can have a short name like x and y, or a more descriptive name like age, car name, total volume. The rules for Python variables are they are like this. A variable name must start with a letter or the underscore character. A variable name cannot start with a number. For example, we don't have 9x as a variable. We cannot have it. A variable name can only contain alphanumeric characters and underscores like A to Z, 0 to 9, and underscore. And variable names are case sensitive. Age is different from this age because there is a difference in A and age also. There are 3 different variables in MacroPython. And the variable name cannot be any of the Python keywords. If you search about Python keywords, you will get all about all keywords in the Python. I brought all the list of the keywords in Python, like and, class, else, finally, if, lambda, or, true, yield. You can see all of them here, and you cannot use them as a name of your variable. Um, let's see here legal variable names like my var. They are totally right. My var, my var. It can be like this, but the illegal variable names that you cannot choose is to my var, that is start by number, and my var that it has a dash inside, and my var that it has a space between. So you cannot choose the variable names like this. Multi-word variables name. Variable names with more than one word can be defined. It can be difficult to read, so there are several techniques you can use to make them more readable. One is camel case. Camel case say that each word except the first start with a capital letter. My variable name, as you can see, M is small and V in variable and N in name, they are capital. This is called camel case. The other format that we have for the variable names is Pascal case, that each word starts with a capital letter. My variable name. So the difference between camel case and Pascal case is the only in the first part. So M in my and V in variable and N in name all should start with the capital letter. And the other one that we have is a snake case, that each word is separated by an underscore character, like my underline variable underline name, and we call it a snake case. We can assign multiple values in to different variables. I mean, it should be either many values to multiple variables or one value to multiple variables. So MicroPython allows you to assign values to multiple variables in one line. For example, x, y, z equal orange, banana, and cherry. They are all a string, and when you can define it in one line. It will knows that the x, if you print them, it will print in output orange, banana, and cherry. It knows that x values is orange, y value is banana, and z value is cherry. And you can also assign one value to multiple variables. That in this case, it's orange that will be assigned to all of this variable x, y, and z. You can see we can do it in one line. And if you print x, print y, and print z, you will see orange, orange, orange in the output. Also, you can do an unpacked a collection. If you have a collection of values in a list or tuple or whatever, MicroPython allows you to extract the values into variables. So this is called unpacking. For example, here we have fruits as apple, banana, and cherry, and we put x, y, and z equal to fruits. The output that you will see if you print them, the output that you will see, it will be apple, banana, and cherry. And when we put fruits, it knows that the index 0, it will be x, the value of the index 0 will be assigned to x, that is apple, and the value of index 1, that is banana, will be assigned to y, and the value of index 2 will be cherry, that will assign to z. Output the variables. We can the MicroPython print function is often used to output the variables. We saw that as a first simple example, we saw the print function, and if you have x equal MicroPython is awesome, and then you print x, you will see in the output MicroPython is awesome. In the print function, you output multiple variables separated by a comma. For example, we have x equal MicroPython, y equal is, and z equal awesome. So if you print x, y, and z, you will get the output as MicroPython is awesome. So you can see we are separating the multiple variables by comma. We can also use plus operator to output multiple variables. MicroPython is awesome. If you concat x, y, and z, the output will be MicroPython is awesome. You should notice the space character after MicroPython and is. Without them, the result would be MicroPython is awesome. So as you can see here, I have a space. MicroPython, when we are connected, then there's a space here, then is here with a space that when awesome is after is, there will be a little space. So the output will looks like more better than this one. For numbers, the concat character works as a mathematical operator. For example, let's say we have x equal 5 and y equal 10. When we print x plus y, we will get output as a 15. You should be careful about here. But for strings, when we use a plus character, works as a concatenating operator. If we have x and the value is 5 as a string, and if we have y and the value is 10 as a string, if we do print x plus y, the output will be 5 and 10. You will see this as an output. But when they are integer, they will be plus with each other, that will become 15. In the print function, when you try to combine a string and the number with the plus operator, Python will give you an error. So for example, here this is int, this is x is int, and y is a string. If you do this, you will get error. So you need to separate multiple variables, these variables with comma, if they are not in the same type. So you should write print x and x comma y. Global variables. Variables that are created outside the function, as in all of the examples above, are known as global variables. Global variables can be used by everyone, both inside the function and outside. For example, we want to create a variable outside of a function and use it inside the function. Let's say we have x equal awesome, and we define my function as and in this my function we have print MicroPython is plus x, and then we have my func that we are defining here. So here we will see as output MicroPython is awesome. MicroPython is awesome. When this function is called, the value of variable x will be awesome, and then we will have MicroPython is awesome, because this is a global variable, and in this function we have access to this variable. Let's see what is the difference between global variable and local variable. If you create a variable with the same name inside a function, this variable will be local, and can only be used inside the function. The global variable with the same name will remain as it was, global and with the original value. Like here in this example, we have x equal awesome, and when we define the function my function and x is fantastic, when we print MacroPython is x, here it takes the local variable that is defined here. MacroPython is fantastic. Uh, but our program, after running this, after calling this function and that printed the MacroPython is fantastic, then we have another print that is print MacroPython is, and here we will get this variable, this x. So it will become MacroPython is awesome. So you can see, even if they are at the with the same name, when we call it, we have access to the global, and when we want to see the output this print, the x will be this local variable. The global keyboard. Normally, when we create a variable inside a function, that variable is local and can only be used inside that function. So, what if we want to create a global variable? If we want if let's say to create a global variable inside the function, we can use the global keyword like here, a global x. So if you have in your function as a mic function the global x variable, and x is fantastic, and when you call this function by my func, and you come here and the variable is fantastic, and when you print MacroPython is x, since this x is global, is defined is in global, then here we have access to that global, even if we are not in that function and we are outside here of the function. So here we will see the result is MacroPython is fantastic. So it's very important, because if we didn't have this global keyword here, x will be local, and you wouldn't see the result as it is here. But since it is global and it's defined here fantastic, then you will see the result MacroPython is fantastic. Overall, if you use the global keyboard, the variable belongs to the global scope. We use the global keyboard if we want to change a global variable inside the function. To change the value of a global variable inside the function, you refer to the variable by using the global keyboard. So we have x as awesome, we define it here, and also we have a global x here that it is defined as a fantastic. And then we have the command mic function, and then we have print MacroPython is x. So let's see what is the output here. X is defined as awesome here, and since this and we come after this, we come here and mic function is called. We will go to the mic function, and here we have global x. This x is defined as a global, so it means that if we define here x as a fantastic, it will be written on this value of x. So in the output, we will see MacroPython is fantastic. This awesome was overwritten by this fantastic. Let's see what are the data types, what we have. The built-in data types that we have is text type, that is str, numeric types, that is int, float, complex, sequence types, that is list, tuple, and range, mapping type, that is dictionary, set types, that is set, boolean type, that is bool, and binary types are bytes and byte array, and non-type, that is non-type. In programming, the data type is an important concept. Variables can store data of different types, and different types can do different things. MicroPython has the following data types built in by default in these categories, as I showed you. Uh, like many other popular programming languages, strings in MicroPython are arrays of bytes that representing Unicode characters. However, MicroPython does not have a character data type. A single character is simply a string with a length of 1. Um, Actually, the square brackets can be used to access the elements of the string. And MicroPython has a set of built-in methods that you can use on strings like len, format, and upper, lower. That they are different methods that you can apply to the string. And uh, there are also 3 numeric types, as you can see here: int, float, and complex. Um, int or integer is a whole number, positive or negative, without decimals of unlimited length. A float or floating point number is a number, positive or negative, and containing one or more decimals. And float can also be scientific numbers with an e to indicate the power of 10. And complex numbers are written with a j as the imaginary part, as we learned in the math that it was aj plus b. And another type that we have is list. And a list is an ordered collection of elements which can be of any type and is mutable. When we say is mutable, it means that you can add, remove, or change items. We have a tuple, and tuple is similar to a list, but it is immutable. It means that you cannot change its contents. Once it is created, you cannot change it. Tuples are often used to store related pieces of information that belong together. We have also a dictionary, and a dictionary is an unordered collection of key value pairs where each key is unique and associated with a value, and you can use a dictionary to store and retrieve data efficiently based on its key rather than its position in the collection. We have set, and set is an unordered collection of unique elements, and sets are commonly used to perform mathematical operations like union, intersection, and difference between two or more sets. And we have booleans, and booleans represent one of two values, true or false. In programming, you often need to know if an expression is true or false. We can evaluate any expression in Python and get one of two answers. And when you compare two values, the expression is evaluated and MicroPython returns the Boolean answer. So you can get the data type of any object by using the type function. For example, let's say we have x equal 5. If we use the type x, the output will be int. So how we can set the data type? Let's say we have x equal hello world, the data type is a string. If we say x equal 20, the data type is int. If we say x 20.5, the data type is float. And when we say x equal 1j, the data type is complex. And this is how we define a list. This is a list of fruit. For example, x equal apple, banana, and cherry. Let's notice this is a bracket here, and this is quotation, and they are separated by comma in the list. And in tuple, we have parentheses, and this is a quotation, and they are separated by a comma. And in dictionary, we have curly bracket and then quotation, um, and we have a key and value, that they are this key and value. For example, here name John, age 36, they are each key value are separated by comma. And we have set, that is a curly bracket, and they are separated by comma. We have x equal true, that is boolean, and we have x b quotation hello, that is says that it is bytes. When we use b here, it shows that it is bytes. And x equal bytes array of 5, it says the data type is byte array. And when we say x equal range 6, it will be the data type of range. And when we say x equal none, the data type will be non-type. So here there is an example. We have x equal name colon John, comma age colon 36. We define a dictionary here. So let's display it, and let's print it. So when we print it, the output will become name colon John and age 36. Is really way of showing. It says that the name is John, and he has 36 years old, for example. And when we print the type of x, we will get this class dict, that it shows that this is defined as a dictionary. So just by using the type x, we can see that what is the type of the variable. Okay, let's see operators. Operators are used to perform operations on variables and values. When we say print 10 plus 5, the output will be 15. The operators are divided into 7 groups, and they are arithmetic operators, assignment operators, comparison operators, and logical operators, bitwise operators, identity operators, and membership operators. In arithmetic operators, they are used with numeric values to perform used with numeric values to perform common mathematical operations. When we say operator plus, it means addition, and this is x plus y. When we say minus, it is subtraction, and it is x minus y. When we say a star, it means multiplication, and the example is x multiply y. When we say a slash, it is division, and it is the example is x divided by y. And percentage is, it means modulus, and the example is x modulus y. And two stars means exponentiation, and its example is x star y. And when we have a double slash, it means floor division, and the example is x slash y. So let's see what is assignment operators. Assignment operators are used to assigning values to variables. Operator Equal is the example x equal 5. It means it's the same as x equal 5. When we say plus equal, the example is x plus equal 3, and it means that x equal x plus 3. So you should notice that x plus equal 3 is x equal x plus 3. And exactly applies to minus equal, and x minus equal 3 means x equal x minus 3. And they are all the same for multiplication, division, modulus, and floor and power. And you should know what does it mean when you write like this. It means this column. So the next operators are comparison operators and are used to compare two values. For example, when we write equal equal, it means equal. It doesn't mean assignment. You should care about it. Equal equal means we are checking the equality of two things. For example, x equal y. When we say not equal, exclamation with equal, it means not equal. X not equal y. This is called greater than, x greater than y, and less sign means less than, and it means x less than y. And greater equal, it means greater than or equal to. An example is x greater than equal y. And less than equal, it means less than or equal to. Then example is x less than equal to y. The next one is logical operators. Logical operators are used to combine conditional statements. Operator and returns true if both statements are true. For example, x less than 5 and x less than 10. If both of them are true, it will be true. But if one of them is not true, it wouldn't be true. And or returns true if one of the statements is true, x less than 5 or x less than 4. And operator not reverse the result, returns false if the result is true. For example, if we put whole of this expression and put a not, it will be exactly inverse of this example. And bitwise operators. Bitwise operators are used to compare binary numbers, and we have ampersand, it is and sets each bit to 1 if both bits are 1. So x ampersand y, x and y. And or that says each bit to 1 if one of two bits is 1. And x or says each bit to 1 if only one of two bits is 1. And we show it like this. And not inverse all the bits, we say not x. And 0 left shift left by pushing zeros in from the right, and let the leftmost bits fall off is shift left. And this is shift right, and by pushing the pushing of the leftmost bits to the right, and in from the left, and let the rightmost bits fall off. And we show it like this. The identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. So is returns true if both variables are the same object. X is y. Is not returns true if both variables are not the same object. X is not Y. Membership operators. Membership operators are used to test if a sequence is presented in an object. For example, in returns true if a sequence with the specified value is present in the object x in y, and not in returns true if a sequence with the specified value is not present in the object x not in y. Okay, let's see control statement. We have three control structures: if else, while loops, and for loops. MicroPython conditions and if statement. Python supports the usual logical conditions from mathematics. Equals is a equals b, not equals is a not equal b, less than a less than b, less than or equal a less than equal b, and greater than a greater than b, and greater than or equal to is a greater than equal b. These conditions can be used in several ways, the most commonly in if statement and loops, and an if statement is written by using the if keyboard. So the example is here. We have a that is the number 33 is assigned to it, and b 200, and we check if b greater than a, print print b is greater than a. So in the output we will see b is greater than a, because when we see here, when we come here and we check the condition, we say that b is 200, that is greater than a, that is 33. So it is true, then this command can be executed. If it was not true, this command wouldn't be executed. If a statement without indentation will raise an error. Okay, let's see here. A is 33, B is 200. If B is greater than A, print B is greater than A. You will get an error and you cannot run it, because when you have if, when you see colon at the end of it, you should have indentation, as I mentioned in the first of this lecture. Else if. The else if keyboard is MicroPython's way of saying if the previous conditions were not true, then try this condition. The example is a equals 33 and b equals 33. If b greater than a, then print b is greater than a, and else if a equals b, print a and b are equal. So the output will be a and b are equal. So because a is 33 and b is 33, this condition is not true, then this command wouldn't be executed, but this if will not executed. But else if say that if they are equals, it means that here we get a true condition, because both of them are equal. So we will see in the output a and b are equal. And else, the else keyword catches anything which isn't catched by the preceding conditions. For example, we have a as a 200 and b 33. If b greater than a, which is not equal because b is 33 and a is 200. So this condition is not true, so this command will not be executed. We come to this one. We say else if a equals b, we have another condition. Let's see. A is 33 and b is a is 200 and b is 33. They are not equal. So this condition is not true, so this print will not be executed. But we have here else. In the case that these two they were not executed, now that we are here and we have else, it means that b is less than a, and it is true. B is 33, and it is less than A, that is 200. So we will see in output A is greater than B. You can also have an else without the else if. For example, in this example, you have if B greater than A, if it is true, then we will execute. But in this case, this if condition is not true, so it will go to the else, and in the else, that means B is less than A, then we will see B is not greater than A in the output. And shorthand if you have only one statement to execute, you can put it on the same line as the if statement. For example, one line if statement is here: if A greater than B, print A is greater than B, and the output you will see A is greater than B. But you can have shorthand if else. If you have only one statement to execute, one for if and one for else, you can put it all on the same line. For example, um, A is 2, B is 330. Print A if A greater than B, else print B. So let's check here. It says that if A greater than B, 2 greater than 330, that is not true. So A wouldn't be printed. Else will be executed. Else print B. So in the output we will see B. We can also have multiple else statements on the same line. For example, we have A as a 330 and B 330. We will print A if A greater than B, else print equal, and if A is equal to B, else print B. And this is a if else statement with 3 conditions. So if we execute it, the output will be this sign. The equal sign will be output. Nested if. You can have if statement inside if statement, and this is called nested if statement. For example, we have x equal 41, and let's see, if x greater than 10, print above 10. And if this is the if that is inside this if. Let's start here. If x greater than 10, yes, it is true condition. Then because x is 41 and this is greater than 10, then we will come here and we will print above 10. You can see in output we have above 10. Then we come to the next line, and it is if x greater than 20. And this is a true condition because 41 is also greater than 20. So we will see print and also above 20, and we can see here and also above 20. Else means that x is less than 20, which is not true because x is 41 and it is not less than the 20. So we can see that here we have two we have nested if, one if that is inside there, another if. The pass statement. If a statement cannot be empty, but if you for some reason have an if statement with no content, put in the pass statement to avoid getting an error. For example, we have A as a 33 and B 200. If B greater than A, pass. Having an empty if statement like this would raise an error without the pass statement. If you don't put it here, you will get error. But if you put pass here, you wouldn't get any error. And we have and or. And keyword is a logical operator and is used to combine conditional statement. For example, test. In this example, we want to test if A is greater than B and if C is greater than A. So we have A 200, B 33, and C 500. If A greater than B, that is 200 greater than 33, and C greater than A, that is 500 greater than 200, then we will print both conditions are true. That in this case, both are true. And we have also OR, and the OR keyword is a logical operator and is used to combine conditional statement. For example, here in this example, we want to test if A is greater than B or if A is greater than C. We have A equal 200, B equal 33, and C equal 500. If A greater than B or A greater than C, it shows that A, that is 200, is greater than B, that is 33. Or A is 200 and it is greater than C. This is not correct, but OR is like a operator that if one of these operand is correct, it will be executed. In this case, A greater than B is correct and is enough to make whole the condition correct. So we will print at least one of the condition is true, and we will see this in the output. Not. The not keyword is a logical operator and is used to reverse the result of the conditional statement. For example, here, test if A is not greater than B. Sorry for this. A is 33, B is 200. If not A greater than B, then print A is not greater than B. Because A greater than B is false, because 33 is not greater than 200. Not false, it is true. So this condition overall will be true. And then that's why we see this A is not greater than B in the output. We have while loops, and with the while, MicroPython has two primitive loop commands. One is while loops and another is for loops. The while loops requires relevant variables to be ready. In this example, we need to define an indexing variable I, which we set to 1. And while loop, we can, using while loop, we can execute a set of a statement as long as a condition is true. For example, print I as long as I is less than 6. So we have this index I and assign 1 to it, and while I is less than 6 colon, we will print I, and in each round I is incremented once. So until this condition is true, we will execute this command inside the while. So first time is 1 is less than 6, so print 1, and we can see 1 here. It I will be I, that is 1, it will be incremented by 1 and it become 2. 2 is less than 6, then print it is true, and then it will come here and print 2, and next it will increment it become 3. 3 less than 6 is true, and it will print 3, and then it will be incremented 1 and become 4. 4 is less than 6 and it is true, and it print 4, and it will become incremented 1 and become 5, and 5 is less than 6 and it is true condition, and it will print 5, and it will become increase and become 6 here, and 6 is less than 6, that is not true. Then while wouldn't be executed, and the output will be only 1 to 5. So you should note that remember to increment I, because if you don't do that, the loop will continue forever, because always is true. The break statement. With the break statement, we can stop the loop even if the while condition is true. For example, exit the loop when I is 3. Uh, I is 1 while I is less than 6. Print I. If I equal 3, break, and I plus equal 1. So in this example, I is first 1 and I is less than 6, and it is true, and we will print I, and we are printing 1. And if 1 equals to 3, this condition is not true, so we will go to the next command, that is increasing 1 and it become 2. 2 is less than 6 and it will print 2, and we have checking here if 2 equals 3, that is not true, so we will go to the next command, and that is incrementation, increasing of 2, and 2 become 3, and then 3 is less than 6 and it is true, and we will come here and we'll print 3, and you can see we see 3 as output. If 3 equals 3, this is become a true condition. If 3 is equal to 3, so this command will be executed, that is break, and it will become out of all the while, so the program is finished. So break, stop the loop. The continue statement. With the continue statement, we can stop the current iteration and continue with the next. So this example, continue to the next iteration if I is 3. For example, we have I equals 0. Uh, let's check the conditional while. 0 is less than 6, and here 0 I, that is 0, become incremented and become 1, and if 1 equals 3, that is not true, then this command wouldn't be executed, so we will go to print I, and it will print I, that is 1 here, and then here we will have here yes, it become 2, and oh sorry, it become 2, and this is it goes 2 and it increment, and then it's the 2 is not equal to 3, so this condition wouldn't be true, and the command continue would not executed, so it will only print I and become 2, and the 2 will be printed as output, and then it become 3, and when it become 3, it's check if 3 equals to 3, and in this case that 3 equals to 3, this condition is true, then it will this continue command will be executed. It will execute it, and it wouldn't go to this printing that printed 3, so we will go to check to the next number, that it is 4, so and it will continue like the 1 and 2. So in the output you can see that we don't have any 3 here, because in the case that it was 3, we had the command continue. So you should notice that in this example number 3 is missing in the result. The else statement. With the else statement, we can run a block of code once when the condition no longer is true. Print a message once the condition is false. You can run this code and see how it is work. In the output, you will see 1, 2, 3, 4, 5, and when it comes else, it says that I is no longer less than 6, because after the while loop is done and all the numbers are printed, then after while there is a else command. It comes here. It means else means that I is not less than 6. Is yes, I is not less than 6. It is 6 now, so it will print I is no longer less than 6. We have also for loops, and the examples is print each programming language in a programming language list. For example, we have the languages list, Java, MicroPython, and JavaScript. For X in languages, for X is a variable in languages, it goes through all the values in this list. It will print it. That's it. This is for. And so the output will be Java, MicroPython, and JavaScript. The for loop is used for iterating over a sequence. Is either a list, a tuple, or dictionary, or a set or a string. This is less like the for keyword in other programming languages and works more like an iterator as found in other object-oriented programming languages. With the for loop, we can execute a set of statements once for each item in a list and tuple and set, etc. And the for loop does not require an indexing variable to set beforehand. As you can see, there is no initial value for the X. We start by for X in languages, and it goes through all the values in the list. And the break statement, we have break and continue both in while loop and both in for loop. So with the break statement, we can stop the loop before it has looped through all the items. So for example, in this example, exit the loop. We will exit the loop when X is MicroPython. We have a list of programming languages, and this list is called languages, and the values are Java, MicroPython, and JavaScript. For X in languages, print X. Okay, the first one is Java. It will print Java. And if X equal to MicroPython, Java is not equal to MicroPython. So this statement, this condition is not true. It will go for the next one. Now X is MicroPython, and it will print X MicroPython. If X equal to MicroPython, here the condition is true. MicroPython is equal to MicroPython. Then this command break will happen, and it will break all the for loop. So we will see only Java and MicroPython in the output. Exactly, we have the continue statement. With the continue statement, we can stop the current iteration of the loop and continue with the next. For example, in this example, we don't want print MicroPython. How we should write it? We have the array of programming languages, Java, MicroPython, JavaScript, and we hold all this variable in the list that is called languages. For X in here this is a mistake. It should be languages. For X in languages, if X equals MicroPython, continue. So first time X is Java, and Java is not equal to MicroPython, so this command continue wouldn't be executed, and we will print X and Java will be printed. The next time it will go to the X will be MicroPython, and this command X equals MicroPython will be true, and we will the continue statement will be executed. So when it is executed, it will pass this iteration, I will go to the next one, that it is JavaScript. So it doesn't print MicroPython. You cannot see MicroPython in the output. So the next time X will be JavaScript, and if JavaScript is equal to MicroPython, that is not true, then continue would not execute it. Then we will have print X, that it will print JavaScript, and we can see in the output the JavaScript. Else in for loop, and the else keyword in a for loop specifies a block of code to be executed when the loop is finished. For example, print all numbers from 0 to 5, and print a message when the loop has ended. For x in range 6, print x, else print finally finished. X start from 0, and it in range is exclusive, is 6 is not inclusive, so it will print from 0 to 5. And else, when it says that else x is 6 or more, so it will print finally finished, and we will see on the output finally finished. So let's see what is range function. To look through a set of code a specified number of times, we can use the range function. The range function returns a sequence of numbers starting from 0 by default and increments by 1 by default and ends at a specified number. For example, for x in range 6, print x, and the output is 0 to 5. Note that range 6 is not the values of 0 to 6, but it is the value 0 to 5, as you can see here. And the range function defaults to 0 as a starting value. However, it is possible to specify the starting value by adding a parameter. For example, range 2, 6 means values from 2 to 6. But 2, 3, 4, 5. 6 is not included. Nested loops. A nested loop is a loop inside a loop. The inner loop will be executed one time for each iteration of the outer loop. For example, print each adjective for every fruit. Oh, sorry for the fruit. I changed the a name, but I am this is, it should be every programming languages. So we have an array of adjective, easy, medium, hard, and the array of languages, the list of languages, Java, MicroPython, and JavaScript. So if we have a nested for loop, that it is for x in adjective, for y in languages, print x, y, the output will be like this: easy Java, easy MicroPython, easy JavaScript, medium Java, medium MicroPython, medium JavaScript, and hard Java, hard MicroPython, hard JavaScript. I mean, the meaning should be logical. I mean that Java is easy, Java is medium, and Java is hard to learn, but this is how the programming looks like. So this is the output here. Error handling. Assume that we have a temperature sensor connected to an Raspberry Pi Pico W over I2C. Also, assume that our Raspberry Pi Pico W reads the temperature data and sends it every 5 seconds to the cloud. This will work fine as long as the sensor is connected, but as soon as that sensor stops working for some reason, for example, hardware failure, or gets disconnected, for example, wiring gone bad or unplugging from the Pico W, the system will crash. To avoid crashing the system, we try to execute critical instructions such as read in a try and except a statement. Since read expect that the sensor to be connected and functional in order to read from it. So this is the prototype of it: try and accept. try, you have some code inside the try, and in the except it will be executed if error in the try block happen. And we have else that execute if no exception, and finally that always executed. So if you notice in the code that we had in the first lecture, that we wanted to get connected the Pico W, here we have a while loop, and in this while loop we should put try and except. In a case that we get an exception occurred because of the problem that I told you, maybe it's a hardware failure or it is a disconnection because we didn't do wiring very well and this is unplugged or whatever, then we can catch this exception error, and we catch it and we continue. So we learn what is the continue. So overall, you can see here, almost all the programming commands that is written here, like while, like try and except, and like continue, and like print. And the only things that we are going to learn in the next topic is the library connected to the MicroPython, like pin, like machine, and I will show you how they are. We should use them and how they are defined. So you should use this try except in your code when you are writing your code, and this is what is the code that you should run on your Pico W microcontroller. So also you will get if you get syntax error, or it maybe it's because you write something not right. I mean, for example, the print function, you write the print the p with a big with a capital P, or you add extra symbols somewhere. So you should care about this syntax error, and it's nice to read this warning. And also the file types that when you are saving MicroPython, please keep your file as a main.py, and it should be py, that shows that this is this is a Python file, and you should care about it. So it would be nice if you read about these warnings and care about it, I mean. So thanks for your time, and I hope you enjoyed this lecture. And if you have any feedback or question, please write me on a Slack. And always, you are very welcome to the IoT Lab in Kalmar and to my office. If you have any question, for sure, I am there to answer you. So, goodbye.